So today I thought I'd look at this mini DC power supply. It's made by Deke Robot and is one of the few products that you buy from China that comes in a nice package. Apparently it uses new low voltage and high current efficient DC to DC power technologies. You can have an input of 9 to 24 volts, maximum 30 volts, so is it 9 to 30 volts? Reverse polarity protection, and two groups of current can work simultaneously without conflict. Over 90% efficiency rate. Well, let's get inside. So, here we go. So there's a plastic box, a cable here, which I think, if I can get into it. So the cable that comes with it is actually in bits. You need to build that up yourself if you'd like to use it. So you'd better have a soldering iron if you want to use this little power supply. But this is quite neat. It's got a input there at the top. Positive centre is at 2.5. Sorry, 5.5, 2.1. I think it probably is. Let's just check that. Yep, that seems to fit quite nicely. The power button on the top, coarse and fine adjustment. And then on the front, is that the front? Anyway, the side panel here, we've got a USB output, 5 volt, 2 amp. Two little pin header sections there on the same 5 volt, 2 amp. And then on the right hand side here, we've got some terminals there and some pin headers for 1 to 20 volt, 2 amp. Well, that's pretty good. So I've not yet made up that cable, but I've no need to because I've got other connectors I can use here. And we can see there we've got a 5 volt output and 12.7. So presumably if I adjust that, yes I can. So my battery bank is at 12.7 currently, or a little bit above, actually more like 13 and a bit. And then I can bring that voltage down, either coarse or fine. We can also see we've got a current reading on there as well. And of course the breadboard is the most obvious application for this little power supply here. We're using the 5 volt rail to power the Arduino, and the 12.8 volts currently is on this bottom rail here, and obviously we'd be able to interface that through MOSFETs or transistors or something like that. I think it's probably fair to assume that the grounds will be connected, so yeah, they share the same ground, the two different outputs. Now this current meter here on the 5 volt rail doesn't seem to be terribly accurate. It's saying it's 70 milliamps is being drawn there, but actually I've got half an amp, and if I turn that up a little bit, yeah, so we're pulling an amp here through the 5 volt USB port, and the mini DC power supply is saying 170 milliamps. Well, that's a long way away, isn't it, from the actual value. Let's just unplug that. That's set to 0. Plug it back in again. No, that current sense is frankly a bit rubbish. Now I've just read the box again, and it does say there is a calibration mode, so if you hold the power button down while connecting the power, the LCD will display 0. So let's give that a go. Disconnect the power, press and hold the power button, reconnect the power, and that's not a 0, is it? Those are, well, that's gobbledygook. And if I release the power button, we do go back to the normal mode. If I plug in a load again now, no, the load's at 1 amp and the meter's reading 200 milliamps. That's disappointing. And now I've got two different meters connected to the two different outputs. I'm pulling 2 amps at 5 volts and at 12 volts, well, we're just pulling 170 milliamps at the moment, but there you go, nearly at 2 amps there at 12 volts, and that's absolutely fine. But 1.9 amps here Can we just see that on the 12 volt side? But on the 5 volt side, this current meter is all over the place. Now I do fancy having a look inside, and I guess there could be some screws under those feet, or it's quite possible that this just sticks together with clips, so we'll see if we can get in. Yeah, I do wonder. Yep, there's some screws. So the screws are out and the top is off, and there's very little to see here on the top apart from that little LCD screen. Everything is on the bottom. And what have we got here? Well, we've got an XL Semi 4005, that's the adjustable buck controller, and a Holtec HT1621B, well that's the little microcontroller or LCD controller perhaps, or both of course. That looks like a MOSFET up there, and an ST, no, there's an ST microcontroller down here, so I'm guessing that's the LCD controller. This is the microcontroller. 2 LM358s and an FD1603. I'm guessing, because that's here in the 5 volt section right next to the inductor and the diodes, that's a 5 volt buck converter. And with fans and DC monitors going everywhere, we've got 30 watts in total on the outputs here, just 2 amps on the 5 volt rail and 1.7 amps at 10-11 volts on the output. And on the input, it's difficult for me to show you this, there it is, everything's fallen over, 32.5 watts, so we are losing 2.5 watts, but 2.5 watts, yeah, do you know what, I make that more than 90% efficiency. That's pretty good. So I quite like this little mini DC power supply, DC to DC buck converter. It's a little bit like my first DC to DC power supply, but in a way that's exactly the market it's trying to capture. I think it's really useful on a breadboard. Yes, the outputs will be a little bit noisy because of those regulators in there, but nothing that a couple of capacitors can't sort out. Hopefully you've enjoyed this video. If you have, please give me a thumbs up, subscribe down below, comment if you can, and I'll see you next time. Thanks for watching.